Alright, so in this video, in the Adept video, we are going to convert to general form. And we're actually going to work with the previous three equations from the previous video. So we have 3x plus 10 equals 7y. Now we want everything in general form. Okay? If we wanted it in slope-intercept form, we would just isolate y, and we would get it in y equals mx plus b form. But what we want to do is, first of all, get rid of any fractions. Okay? Well, that's no problem, okay, because there are no fractions. The next step is to set everything equal to 0. Okay? So it doesn't matter which side you choose, but because there are fewer terms on this side, I would say that's less work. So let's subtract 7y from both sides, and I'll just squeeze it in here. And there we go. So this is going to give me 3x minus 7y plus 10 equals 0. Okay, and we are done. There are no fractions. This number here in front of x is positive. Everything is equal to 0. We're done. All right, so the next one I believe requires the least amount of work. Okay, there are no fractions. Everything is set equal to 0. Okay. The only problem is, as I explained before, the number in front of the x is negative. Okay, so to fix that, okay, we just need to change the sign. Now what I've seen kids do before is they say, oh, this is negative, so I'm just going to magically change it to a positive number and keep everything else the same. That's not math, okay? That's not how you do it. Okay, you can also actually divide by -1. You get the same result, but I'm going to multiply. So multiply everything by -1. And multiply that side by -1. Okay, I'm going to apply distributive law. So I'm showing a lot of work here, but it's important for you to understand why I get the answer that I do. So when you multiply a number by -1, the only thing that changes is the sign. So once you get good at this, you can just change them in your mind. You don't have to write all this stuff down. So this will give me positive 4x, positive 9y, take away 50, and that of course is still equal to 0. So that is now general form. Alright, so the last equation, well, everything is set equal to 0, so that's okay, and the number in front of the x is positive, so the only problem is we have a fraction. Okay, well, the fraction is 2/3. Well, what that means is you're multiplying by 2, but then you're dividing by 3. Okay? So really the only culprit that we have to eliminate is the 3. So the only way to undo dividing by 3 is to multiply. Now I can't just multiply the first term because I feel like it. I have to multiply everything by 3. And I multiply that side by 3 as well. And there we go. So I'm going to apply distributive law, just showing all my work. All right, so this is the only tricky part. What is 3 times 2/3 x? Okay, well, 3 times 2 divided by 3, well, the 3's just cancel. So I'm just left with the 2. So this gives me 2x, and this thing is slow. And then I have 3 times positive y, so that is plus 3y. 3 times negative 25, remember, watch your sign, that is negative 75. All right? And 0 times 3 is 0. Okay, so now this is in general form. All right, so for the next 6 examples, we're just going to practice converting the equation, however it is written, to general form. Okay, so for the first one, we have y equals negative 2x plus 1. Okay, so first of all, we need to, let's get rid of any fractions. Well, there are none. The next step is to express everything on one side equal to 0. It is your choice. You can express everything on the right, so you'll have 0 on the left, or you can express everything on the left with 0 on the right. It's totally up to you. Most people choose the left-hand side because they're more comfortable, but it really doesn't matter. Okay, so I need to add 2x to both sides, but I also need to subtract 1 from both sides. Now in this case, I'm actually not going to show that, just the result. So I have y Remember, I have to add 2x to both sides, so that's going to be y plus 2x. But I also said I had to subtract 1 from both sides, equals. And of course, after I do that, there's nothing left. Okay? All right. We're actually done. Okay? The terms aren't written in their proper order, but why not? 2x plus y minus 1 equals 0. Okay, so there are no fractions. Everything is set equal to 0, and this number here, the coefficient in front of x, that is positive. So this example is done. But recapping my technique, from the original equation to this first line here, again, it looks as though these two terms just moved to the other side and we just switched the signs. Okay? It's important to remember again, you're not moving. Okay? It just looks like you're moving. Okay? You're treating both sides the same. So, though I didn't write it, what I really did was this, is I added 2x to both sides, so it canceled on the right, but then it had to be written on the left. Okay? And I subtracted this 1 from both sides. Okay, so I'll write it there, it doesn't matter. And I'm running out of room here. That's one of the reasons why I didn't show it. Okay, that's really what I did. Okay, I applied these operations to both sides, so the end result, it looks like they moved, but really they didn't. So keep that in the back of your mind. Okay, next example. There are no fractions to deal with. That's nice. So let's just express everything on one side. So that would give me 2y. And this is positive 3x on the right, so I'm going to subtract it from both sides. And I'm also going to add 1 to both sides. Hence, on the right, there's nothing left. Okay. I'm going to reorder the terms. Okay. Looks good for the most part. The only thing is, this number here is negative. Okay. It needs to be positive. Okay. So I showed you one way is you just multiply everything on both sides by negative 1, and that will change the sign. Okay. So this becomes positive 3x, take away 2y, minus 1 equals, and that's still 0. Okay? All right, so there's actually another way to get the same answer, a bit faster. Look at the original equation. Notice how the x term was already positive on the right-hand side. Okay? By writing it on the left, that's why it became negative. So if you observe that in the beginning, you might actually choose to express everything on the right side instead. So in this technique, I'm just going to subtract 2y from both sides. So that leaves me with 0 equals 3x minus my 1 minus my 2y. Okay, I'll just reorder the terms. Okay. So by doing it this way, there are no fractions, of course, but the sign is already correct. Okay, and you notice that this and this are exactly the same. They're just flipped around. Okay, so either technique is fine. Do whatever is most comfortable for you. Okay, so next, we have a fraction to contend with. So the only denominator that we have to worry about is the 7. So that means we're dividing by 7. So that tells us the only way to get rid of it is to multiply everything by 7. Okay, now you can multiply out the denominator on both sides now, or you could do some shifting around and then multiply. It is up to you. Okay, so I'm going to do the multiplication first. Why not? So I need some room. So I'm just going to write out the equation again so that I have some space. Okay, now I'm going to multiply everything by 7. So I need those brackets there. So 7, and that gets multiplied by 7. That doesn't require brackets. So this gives me 7y equals, so now let's just apply distributive law. So 7 times 2 over 7. Well, the 7's just cancel. That becomes 1 over 1. So the only parts remaining are the 2 and the x. So this becomes 2x. 7 times negative 5, watch your signs, that is minus 35. Okay, so fractions are gone, and I need everything on one side, but notice how this is already positive. So if I express everything on the left, which you can do, this will become negative, and then I would have to apply the sign reversal technique, so it's a little bit more work. So what I'm going to do instead is put everything on the right. I'm just going to subtract the 7y here, and it doesn't matter where I write it, I'll tack it onto the end here, because there are no other y's here to subtract from. So this leaves me with 0 equals 2x, and I'll just change the order, so that is minus 7y minus 35. Okay, that is now in general form. We're done. All right, so the next one, we've got a bunch of minus signs in there, so nothing wrong with that. We just have to be careful. We do have a fraction to deal with, so to undo the division by 5, we need to multiply everything by 5. Okay, so I'll do that now. I need a bit of room for that, so I'm just going to write this out again. Now there are different techniques to doing this. You can do things in different order, as long as everything you're doing mathematically is correct. Okay? So I'm going to multiply by 5. Okay, now I can't just put a 5 here like that, because if I do, that'll say 5 minus y. Okay, and that's not what we want. So I'll put some brackets here. Now it's multiplying by 5. Okay, so 5 times negative y is negative 5y, and that's okay. All right, so now we have, on the right, 5 times negative 2 over 5. Well, the 5's cancel, so I'm left with the negative 2x. So don't forget about that minus sign. And then 5 times positive 8 is 40. Okay, so the fractions are gone. Now we need everything on one side. I would say in this example, it would make more sense to express everything on the left, because the x term on the right is now negative. So expressing everything on the left, everything becomes positive. So I add 2x to both sides. Okay, that minus 5y is still there, and I'm also going to subtract 40 from both sides. So that leaves me on the right with 0. All right, next example. Notice how the x is actually written in the numerator this time. That's fine. It could just as easily have been written out here in the middle. Okay, but we do have a fraction to get rid of, so we're going to have to multiply everything by 2. And I'll write it out again, why not? So I get 5x over 2 minus 6, and that is equal to 7y. All right, so let's multiply everything by 2. So I need brackets here, so I can use distributive law. And multiply this by 2. Okay, well, I need some brackets here. Okay, so that is now 7y times 2. So let's apply our distributive law. 2 times 5x over 2. Well, the 2's just reduced to 1 over 1. In other words, they cancel. So I'm just left with 5x. That was easy. 2 times negative 6 is negative 12. That's equal to, and 7y times 2, that's 14y. Okay, so the fractions are now gone. Okay, the x term is already positive on the left, so I think it makes sense to put everything on the left. So that stays, which means I subtract this 14y from both sides. And that minus 12 still there, but everything is now equal to 0. Okay. So that is in general form. All right. Now for the last example, this one is a little bit trickier, not just because we have two fractions, but because the denominators are different. Okay. So this one's being divided by 3, so if we multiply everything by 3, that will take care of that. But we also need to take care of this one at the same time. This one is division by 2. Well, if you multiply by 2 and you multiply by 3, that's actually the same as multiplying by 6, right? So that's actually also the lowest common denominator. that is 6. Okay. So if we have more than one denominator going on, we actually multiply by the LCD. So we have y equals, I'm going to leave a space here, 1/3 x minus 5/2. Okay, and now we're going to multiply everything here by 6. I'm just going to leave myself a little bit more room here. There we go. I'll put that equals back in there, which means I have to multiply the left by 6 as well. Okay. Actually, in theory, you can multiply both sides by any number you want, but you want to multiply by the number that's going to give you the answer you want. So 6 times y is 6y. It's pretty easy. Okay, so now's where you have to be careful. Please don't rush these. So we have 6 times 1/3. Okay, well, the 6/3, that reduces to 2. Okay, so you can think of this as 2 times 1. Okay, so this is going to give me 2x. Another way to look at it is this. There's always an invisible 1 under here. Okay, so tot times tot. 6 times 1 is 6. Bottom times bottom, that is 1 times 3. So 6/3, that also reduces to 2. So you get the same answer. Okay, so I'm just applying distributive law. Okay. So next one you have to be careful. First of all, the sign. This is positive, but this is negative. So positive times a negative is negative. So I'm actually going to get that minus sign in here right now. Now I don't have to worry about it. Okay. So forget about the minus. We've already taken care of it. So we know that 6/2, okay, that reduces to 3. So you can think of this as 3 times 5, which is 15. Okay. If you're not comfortable with that, you can try this. 6 times 5 is 30. 1 times 2 is 2. So 30/2 reduces to 15. Okay. And again, I don't have to worry about this minus sign here because I already took care of that earlier. So the fractions are now taken care of. So this coefficient in front of x is already positive. So I'm going to express everything on the right. You don't have to, but so I need to subtract 6y from both sides. So that gives me 2x minus 6y, and I still have that minus 15. Okay, so there's a bunch of examples on how to convert to general form.